Yes, so good day everyone. My name is Arvin Iberkala, and here in this video, we'll find the inverse of the matrix using Gauss-Jordan elimination. So we have here our given matrix A, which is equal to 3, negative 2, 4, 1, 0, 2, 0, 1, 0. So in finding the inverse of a matrix using Gauss-Jordan elimination, first thing that we need to do is to first put the coefficients or the entries of matrix A here. We write it all here and put a vertical line bar that will separate the identity matrix. So we call this now as an augmented matrix. So as you all can see here in our given, if we take a look at in our row 2, the leading coefficient here is already 1. And also if we take a look at the third row, the middle coefficient here, the row 2 is already 1. So if we try to analyze for us to lessen the work in finding the inverse of this matrix A, all we need to do is just to interchange the rows as well as interchange the rows here in our identity matrix. So we make our row 1 as our new row 3, we make our row 2 as our new row 1, and we make our row 3 as our new row 2. So this is what it looks like now. 102 as our first row, 010 as our second row, and 3 negative 24 as our third row. So since that the leading coefficient here is 1, second thing that we need to do is to make the entries below 1 become 0. So since the entry here is already 0, we'll now move down here. So our goal here is to make this entry here 0 using the Gauss-Jordan elimination method. So in using the Gauss-Jordan elimination method, we have to normalize this entry here by multiplying its additive inverse, so the pivot entry, which is 1 from the row 1. So the additive inverse of 3 is negative 3. So we multiply negative 3 to the pivot R1. Negative 3 times 1 is equal to 3 plus 3. So this will be the formula that we will be using here. We multiply negative 3 times 1 plus row 3, which is 3. So now it becomes 0. Same as true with the other columns. Negative 3 times 0 is equal to 0 plus negative 2 is equal to negative 2. Negative 3 times 2 is equal to negative 6 plus 4, negative 2. Negative 3 times 0 is equal to 0 plus 1 is equal to 1. Negative 3 times 1 is equal to negative 3. Negative 3 plus 0 is equal to negative 3. Negative 3 times 0 is equal to 0 plus 0 is equal to 0. So this will be the resulting matrix using this. So we now here our new row 3, which is the result from multiplying the additive inverse of 3. So as you can see now, all the entries of 1 here is already 0. So the second thing, the next step that we need to do is to make the entries in the middle become 1. So since it's already 1, we should proceed. So the next thing that we should do after that is to make the entries above 1 become 0 and below 1 equals 0. And since the entries above 1 is already 0, should proceed to the entries below it. So -2. So our goal here is to make this 0 also. So we use the same process like what we did in the previous matrix. So we multiply the additive inverse of -2, which is 2. So the pivot entry, which is 1, plus row 3, all the entries of row 3. So we start 2 times 0 is equal to 0 plus 0, 0. So it remains 0. 2 times 1 is equal to 2, plus -2 is equal to 0. And 2 times 0 is equal to 0 plus -2. So we write down -2. 2 times 0 is equal to 0 plus 1. So 1. 2 times 0 plus -3 is equal to -3. 2 times 1 is equal to 2 plus 0, copy 2. So now we proceed to the next step. So our goal here is to make this entry here for it to become an identity matrix. We have to make this entry here become 1. So in order for us to make this entry here become 1, we have to multiply all the terms to its corresponding row by its inverse. So the inverse of -2 is equal to -1/2. Okay, so we start -1/2 times 0 is equal to 0. Just copy 0. -1/2 times 0 equal to 0. -1/2 times -2 is equal to 1. -1/2 times 1 is equal to -1/2. -1/2 times -3 is equal to +3/2. And -1/2 times 2 is equal to -1. Okay, so now we're done. So as you can now see, we're already one step closer to achieving our goal here, which is to make this entry of the left side of the augmented matrix as identity matrix. So the next step that we need to do is to make all the entries above this one become 0. So since this entry here is already 0, we proceed to 2. So our goal here is to make 2 become 0 by applying the same process that we did a while ago. We multiply the additive inverse of 2 to the pivot entry, which is to 1, and add to the entries of row 1. So we start -2 times 0 is equal to 0 plus 1, 1. -2 times 0 is equal to 0 plus 0 is equal to 0. -2 times 1 is equal to -2 plus 2 is equal to 0. -2 times -1/2 is equal to +1. +1. -2 times 3/2 plus 1 is equal to -2. -2 times -1 plus 0 is equal to 2. So now, since that we have already the values here of the augmented matrix on the left side become an identity matrix, we all know, according to the properties of a matrix, the matrix augmented with the identity matrix, and once we use the Gauss-Jordan elimination to come up with an identity matrix on the left side, the right side of the augmented matrix is the inverse of the original matrix, which is the A. So we have here already the values for our inverse matrix A. We have 1, negative 2, 2, 0, 0, 1, negative 1 half, 3 halves, and negative 1.